Good morning. Welcome to the first lecture in Foundations of College Algebra. We're going to deal today with equations and what you can do with equations. Okay, when we have an equation like x plus 2 equals 9, what we're really interested in is what are the solutions, what are the roots, what are the numbers that make this x plus 2 equals 9 true. When we find those solutions, what we have are a way to identify categories of equations. These equations, anything that has the same roots, same solution set, are called equivalent. And basically, they're the two equations that are fundamentally the same. So what can we do with them? We can add or multiply the equation as we will. Okay, so what basically the rule says is if A equals B, if we have an equation, A equals B, then you can add any number you want to the left-hand side as long as you add it to the right-hand side, as long as you're being fair. So that basically means you can add any number you want to both sides of the equation at any time, and it doesn't change the equality. Now notice, if this c that we've got here happened to be a negative number, then that would be a subtraction property. We don't bother to write it down because, frankly, why should we write it down? It's kind of implicit there. Now, what about multiplication? If a equals b and we have some number c, notice it's not equal to 0. Then we can take that number and multiply by both sides, and that would give me a times c is equal to b times c. It retains the equality as long as c is not 0. Now notice, it says c is a real number, so c could be a negative number if you wanted. Or c could be a fraction. If c were a fraction, this would in essence be a division problem. So what it would say is a equals b, and c is some fraction, then a times c, that would be the same as a divided by c, is equal to b divided by c. So even though this is multiplication, it also does division. Isn't it nice when a rule can do double duty? So a linear equation in one variable, ax plus b equals 0, where a and b are real numbers, and a is not 0. Now, if a were 0, we'd have no value for x. We'd have no x term here because the coefficient would be 0. So this would, in essence, not be a linear equation. A linear equation's got to have a variable. A linear equation is called first degree because the greatest degree is 1. The degree is the biggest exponent you can find in the equation. So this one, 3x plus square root of 2 equals 0. X to the first power, that's a linear equation. 3/4 of x, x to the first power, linear equation. 5/10 times x plus 3, x is the first degree, linear equation. Now, square root of x. Square root is really x to the 1/2 power, not linear. 1 over x, okay, that's x to the first power, but since it's in the denominator, it's really considered x to the negative first power, not linear. X squared, not linear. Linear, not linear. So how do we solve this? 3 times 2x minus 4 equals 7 minus x plus 5. Now remember, you have those rules you're going with. You can add anything to one side of the equality as long as you add it to the other side. You can subtract anytime you want. You can multiply anytime you want. You can divide anytime you want, as long as it's not 0. So what are we going to do first? We're going to use the distributive property. So we're going to multiply 3 times 2x gives me 6x. 3 times 4 gives me 12 equals 7 times. Now you see we've got a minus here. That's the same as a negative 1. So we're going to distribute that negative 1 inside this parentheses. So negative 1 times x is negative x. Negative 1 times 5 is negative 5. So we have 6x minus 12 equals 7 minus x minus 5. Now, we're going to combine our terms. I've got a 7 here and a 5 here. 7 minus 5 is 2. So now I have 6x minus 12 equals 2 minus x. Now, I want to have a situation where all my variables are on one side of the equality, all my numbers on the other side. I like my variables on the left-hand side. I'm sorry, that's just the way I am. So, I'm going to get rid of this x on the right-hand side by simply adding an x to the right-hand side. If I add an x to the right-hand side, I've got to add it to the left-hand side. So that's going to give me 7x minus 12 equals 2. Excuse me. Now I got to get rid of this negative 12. I don't like it. I want all my numbers on the right-hand side. So to get rid of this negative 12, I'm going to add 12 to both sides. When I do that, 7x minus 12 plus 12, well, that's a 0. I just added a 0 to it. So if I add 12 to this side, I'm going to add 12 to this side. So that's going to give me 7x equals 14. Now that I have no numbers, all my variables on one side, all my numbers on the other side, I can use the distributive property. Divide by 7, divide by 7. So x is equal to 2. Make sense? Okay, what I'd like you to do is stop right now, stop the video, and try doing this problem. So go ahead and write it down and try solving it. When you come back, we'll show you the solution and you'll see if you got it right. So go start the problem now. Okay, I hope you're back. What we're going to do is when we're dealing with these fractions, one of the things we've got to deal with is the common denominator. Now, one way to find the common denominator is multiply 3 times 2 times 4 times 3. Well, 3 times 2 is 6, times 4 is 24, times 3 is 72. That's a good common denominator. But it's a big common denominator. So the next thing you do is take 3 times 2, that's 6, times 4 is 24. That's a big common denominator, and that works just fine, but it's not the smallest. You can also take 3 times 4 is 12. Will 3, 2, 4, and 3 all divide into 12? Yes. So I'm going to use that as my common denominator. So I'm going to multiply the left-hand side by 12. I'm going to multiply the right-hand side by 12. When I do that, I end up doing a distributive property, and this gives me my equation. So I end up with 3 goes into 12 4 times. 1/2 times 12 is 6. 1/4 times 12 is 3. 7/3 times 12. Let's see, 3 goes into 12 4 times. 4 times 7 is 28. So now I have this equation, much simpler. All my fractions are gone, but it's still not quite there. So now I have 8x plus 16 plus 6x equals 3x minus 28. So that gives me 8x plus 6x is 14. Oh, I made a mistake. I got a t there. That should be an x. My apologies. Equals 3x minus 28. Now I'm going to move my x's over to the left-hand side. So 14x, I'm going to subtract 3x here. That subtract 3x there gives me 11x. Now I have a 16 here and a 28 there, so I'm going to subtract 16 from this side, subtract 16 from this side, so it gives me 11x equals 16 plus 28 is negative 44. Now divide by 11, x is negative 4. That is the one and only one answer that will solve that problem. Did you get it right? I'm pretty sure you did. Now, when we're doing these, we're looking for one of three things: identities, conditionals, or contradictions. Okay, if every value you can choose solves that problem. If you plug in a 1 in here, it solves it. If you plug in a 7 in here, it makes it equal. If you plug in a negative 32 in here, it makes it equal. That's called an identity. No matter what you do, you don't find a single answer. You find a whole lot of answers. Well, a whole lot of answers isn't all that useful to us. So when we find identities, we have a situation where we don't have anything all that useful. Now, if I have 2x equals 4, where I can divide by 2 and divide by 2, and it gives me x equals 2, there's one and only one answer. When that's the case, we have a useful situation. That's called a conditional. It will have, for a linear equation, one and only one answer. If the equation has no answer, it's called a contradiction. Find me a number where x is equal to x plus 1. Find me a number I can plug in there, and I plug in there to make that a true statement. Well, you can't. There isn't one. So we have to determine, when we look at a system of equations, do we have an identity, a conditional, or a contradiction? Why? Identities have lots of answers, none of them particularly good. That's not useful. Contradiction has no answers. That's not useful either. But conditionals have an answer, and an answer is a good thing. That's what we're hunting for. When we look at this, I'm going to distribute that negative 2 across the equal sign, so that's going to give me negative 2x minus 8 plus 3x is equal to x minus 8. Now I'm going to combine my terms. 3x and negative 2x is going to be 1x. So that's going to give me x minus 8 equals x minus 8. Nuts! I can't do much with that. I can add 8 to both sides. That would give me x equals x. Then I can subtract x from both sides and give me 0 equals 0. And that's not very good. That's not useful. Basically what that means is no matter what number I put in here, this thing's true. Uninteresting. Not useful at all. Pardon me again. Let's take this equation. 5x minus 4 equals 11. Okay. Add 4 to both sides. Gives me 5x equals 15. Divide by 5 on both sides. X equals 3. One and only one answer. That's called a conditional. Useful. This is what we're after. Now look at this one. 3 times 3x minus 1 equals 9x plus 7. I'm going to distribute the 3 across throughout the term. So that's going to give me 3 times 3x is 9x. 3 times 1 is negative 3. Equals 9x plus 7. Subtract 9x from both sides. Gives me negative 3 equals 7. Can you find any number that will make this a true statement? No. You can see it's foolish. It doesn't make any sense. This is called a contradiction. Very not useful. There is no answer. We can write that as the null set, but frankly it's not all that useful, so we really find it valuable to do it. So the 3 ways we can deal with these. Number 1. So the 3 kinds of systems we have. Number 1 is an identity. Unuseful. Identity happens when we end up with a statement that says 0 equals 0. Unuseful because there's an infinite number of solutions. Conditional. One and only one solution. Very useful. That's what we're hunting for. And then a contradiction. We end up with no answers. Again, not useful. So a formula is an example of a linear equation. This is a formula for simple interest. Okay, interest, the amount you make, the amount your money grows, is equal to your principal, what you start with, times rate times time. Simple enough, right? Now what if we knew the interest and knew the principal? We wanted to find the time. So I know the principal, I know the rate, I know the interest, but I need to know the time. What we can do is really pretty simple. We're going to take that formula, and since we got principal times rate over here, we're going to divide by principal and rate. So those PR and this PR are going to cancel, so that means time is interest divided by principal times rate. So this becomes the formula. This is the same formula that we can now use if we know the principal and we know how much money we raised, we know the interest rate, we can now figure out how much time takes to do it. Now, if you've got a certain amount of money in the bank and you want to increase it to a certain amount, let's say you have $1,000 in the bank and you need $1,500 to go on a nice trip, and you've got 2 years and you've got an interest rate you can get of 4%. You now have a formula that will allow you to figure out how much money that is. I want to get $500 extra dollars. I'm going to start with my 1,000, and my rate is 4%. This will tell me how long it'll take for me to grow that money to that point. Okay, does this make some sense? Okay, so here's what I want you to do. Take a look at this, think through it, make some notes, and start working on that first homework assignment. And we will reconvene for the next week's lesson. Okay, so the first thing we're going to do is we're going to get that P over on the other side. So we're going to do that by subtracting P from both sides. So it says A minus P is equal to principal times rate times time. And basically what this is the total amount you end up with. So when we take the total amount you end up with minus what you started with, we're looking at your gain. So this would be the increase. Okay, so A is equal to P plus P times RT. So basically all we did was move the P back over on the right-hand side. Okay, we're going to factor out the P. So amount is equal to P, the principal we're hunting for, is equal to the amount divided by 1 plus RT. And we can write it like this. Now, why would you use that? Let's say you knew how much you started with, and you knew how much you ended up with, and you want to figure out what your rate is. So you're trying to figure out, I know how much money I have in the bank right now, and I know my rate, and I know my time. I want to find out how much I started with, so I can figure out how fast it grew. So P is going to allow me to tell you how much money, how much your value increased over time.